Today we are delighted to welcome Merav Opher from Boston University and a past Radcliffe Fellow. Welcome. We're so happy to have you here.
And I'm delighted. And we're sitting in a building that I loved being as a Radcliffe Fellow.
Merav, we're here today because you've just published a very exciting paper in Nature Astronomy. Why don't you tell us about this discovery that is now out in the world?
So we think that what happened 3 million years ago, the Earth and the Sun, the solar system, encounter a very massive cloud. We call this massive cloud local Linux of cold cloud. So the heliosphere is our home in the galaxy and has a croissant shape. And the heliosphere is a wind that comes from the sun. The sun has its own wind. It's particles that emanate. And as the sun moves through the galaxy, that wind goes with it. And it gets deflected, forming a bubble called the heliosphere. So the sun, throughout its history, was moving, carrying its heliosphere with it. What happened 3 million years ago, that the sun, with its big heliosphere that engulfs all the planets, encounters something way more massive than usually it's encountered, was a cold cloud. That cold cloud was also moving. So the heliosphere and the cold cloud collided. Think about a tsunami, engulfed all the heliosphere, and very much like as you will compress a balloon, compresses to distance that are smaller than the distance between Earth and the Sun. So Earth suddenly was outside the protective bubble, the heliosphere, embedded within that cold cloud, that tsunami. And the heliosphere deflated to a bullet-like shape and remained like that throughout the crossing of the cold cloud. So exposing Earth and all the planets to massive amounts of hydrogen, to an increased radiation, to way more dust. And there are several works that speculated that increase in hydrogen, increase in radiation could have implicated ice ages. But as the sun continued moving and the cold cloud continued moving, they passed through each other. And as the sun left the cold cloud, the pressure was off, and it's almost like you stop compressing a balloon. The heliosphere inflated back again to protect all the planets, including Earth. So Earth was inside the protective bubble, back to a heliosphere that we think looked like a croissant shape. And this is where we are right now. So we're still trying to quantify. This paper at least say we encounter a very important cloud that shrank the heliosphere and exposed that to a much more extreme environment. And most likely there would be implications for the Earth's climate at the time. So this still need to be explored. Yeah.
There's a lot more to explore.
Exactly.
Yeah.